Yep, I'm on what seems like it's the school computer.
Yeah, but you should have access to HECRAS through that now.
Yeah.
Yeah.
Is that something that we can all do, or is it only HACRAN?
Well, they have to kind of give. They have to give permission for you to use. So now they've given to people that have Macs, just because otherwise you
cannot download. Okay.
Yeah, you cannot download it. So they've only given access because obviously today we're not in, and it's the time that you have access to the labs. But do you have a Windows computer, Catalina?
I do. I have a Mac and a Windows, but I'm currently using the Mac.
Okay. Because anyway, it will be much easier than connecting remotely. So at the minute, if needed, I can ask for access, but it won't be instant. So it would be easier for you, I think, to install it on.
Okay. There's a tutorial of how to install it on Moodle, no?
I've put the link, and it's very straightforward. You just press. There is just one button, and you install.
Where's the link?
So it is on the Moodle page.
Okay. Okay.
I can just send it in the chat because I have it open here. So download HECRAS. There we go. So our chat. There you go. In the meantime. But I thought I will start first with a bit of a plan of how I think we can do today. That changed a bit. So for the people that just joined, I hope you're all safe and managed to get your email of not going outside of your house before you were on the move. A few of us were already on the go. I had almost made it to Chatham by the time I got the email from the university. So I was almost there and then caught a train back to London. So for today, I've put a note for myself to start recording because otherwise I forget, but I've started recording. I thought I'll just give you some general information for a few things. Then I wanted to show you what material I've put on the Moodle page and then discuss your coursework. And then I was thinking we can run it a bit like a tutorial, that I will be on the call. You can work on your coursework. And if you have any problems installing the software, connecting, any problems with what we're doing last week, I can actually help you go through it. Okay, so who do we? We're still missing a few people, but we'll keep going. So one thing I wanted to let you know is about the NSS, the National Student Survey. So before we even start, you must have gotten an email from Ipsos Mori. It looks a bit weird if you haven't seen it. But because you're final year undergraduates, it's just the national survey we use that you can tell your views about how your whole course is working, how you have access to different things, how you're enjoying it, and so on. It does take only 10 minutes and it is anonymous, so you can do it in your own time. There is a link directly that you can connect, but you can also just go to the studentsurvey.com and then do it from there. I just want to say that sometimes with feedback, people tend to be more open in giving feedback if something is not going well, but it's also very important if you're enjoying something, if something is going well, to also mention it, because it helps us as well to get feedback on what things are going well and what you're enjoying, and at the same time, if something is not going well, to actually apply it and see how we can improve it. Cecilia, I don't know if you want to add anything about the NSS.
Yeah, so a lot of times when we look at these NSS reports, when they come back, some students just do it as a pro forma and check straight down the middle.
Yes.
We want you to go ahead. You know, it doesn't have to be straight down the middle. If there's something you don't like, you don't like it, and that's okay. And if there's something you really like, that's fabulous. I gather straight down the middle isn't something that we really want everyone to do. We do want you to take the time, and then there is the area for being able to comment about what you're doing and any issues you're having. Last year I was really bad, and I blame myself for any poor feedback we got, because the software crashed and the students couldn't use the software, and it turned into a nightmare. And I said, just put it on the NSS. So we were really unhappy, and they did. And so I'm not encouraging you to do that this year, okay?
But essentially, it's just a 10-minute survey, and it sounds, you get the emails and you might just ignore it. But if you have 10 minutes, it's really helpful to the university and to us, because we are putting a lot of effort on different things. And obviously, if something is not working, that's also very important to know and to actually record it.
Yes, because that's the other thing we're doing is we keep trying to tweak the modules and change the modules every year so they're not exactly the same, trying to improve what we're giving you and to give you new and better tools. And so getting that feedback is very useful to us.
Exactly. So I just wanted to, because maybe some people just get the email from Ipsos Mori and then they are not actually aware of what it is. So it is a survey that goes to all final year students in all universities across the UK. And it's just important to, use it as a tool. So I just wanted to say what it is, because the deadline is approaching in a month or so, I think. So the other thing I wanted to say is we are in the process with Cecilia of planning another site visit for you. We're trying to arrange to go to HR Wallingford that has all the laboratory facilities I talked to you about. So we don't have details yet, and if it's possible with their COVID rules and so on, but it is in the process. And if so, I'll get in touch and see which days work best for everyone and how we can do it. So we can all go, because that would be a very nice thing to see the place. Because I realized when I was talking to you about modeling, laboratory or computer modeling, I used a lot of their examples, and it's just a nice place to be able to go and visit. Okay, in terms of IT news, this is what I wanted to discuss. So now the IT people are downloading HECRA 6.1 as well on the university computers. But I've told them to leave the previous one in case you're more comfortable and you start working on that one. That's up to you. And it is completely up to you in which version you decide to use. And I'm happy to do videos on both. They tend to work with the same buttons with one or two differences. But if you need anything extra, you ask me and I'm happy to do it, because I'm using now, I have both on my laptop.
I'm gonna interfere just a second. Alistair has said that he's made Stephen able to get access. So we need to send Stephen the instructions. Okay.
So yes, for the people that have a Mac, let me know, and then the IT has to grant you remote access. It's not ideal. It's better to be using a Windows, but obviously when you're working from home. So just get in touch, and in a second I'll just forward, or Cecilia, if you want to forward it to Stephen, just so we can give him access. So there is a set of instructions, but we have a way. So in general, it's better to have it on your laptop. It works better than having everything remotely. But we are trying to accommodate everyone. Okay, so now in terms of the Moodle page, I'll just keep that here and then open our Moodle page and take you through it here. So in terms of the Moodle page, I have now, if I close this and this, I have now separated the two terms on Moodle, just so it's easier that you can go into all the HECRAS information in one place. Oh, Megan is in the lobby. Okay. Let's keep going. Good. Okay. So yeah, on the Moodle page, you have now 2 sections here, term 1 and term 2. So you have all the information, the video for tutorial 1. I did, as you asked, a video for tutorial 2. There is no sound because this week I lost completely my voice. It's coming back now, so you can hear me. But sorry, it's just Megan is trying to get into our call. Can you hear us, Megan? I'm not sure. So yes, I did a video as well going through tutorial 2. So if there are any questions, you can ask me. There is no sound because I had 0 voice, so I just didn't even attempt to make you hear me because there was no voice coming out since Saturday. Then I have uploaded a file here called HECRAS troubleshooting. So from all the
Has everyone lost sound?
No, I think Joanna has frozen and is going to have to leave and come back, go out and come back in. I don't know if she can hear us. I'll send her a text. You froze. Okay, I think she's gone out now.
Can you hear me now?
Yes, Joanna, you might have to turn your video off.
No, it's just my connection crashed completely, but yes, I will turn my video off while I speak.
Yeah, it's when we have nasty weather, it's a pain, so
Okay.
go for it.
Okay, while I share my screen, I'll turn my camera off and then so I don't know how much you heard from what I was saying. I was saying that on the Moodle page, which now does not want to work. Oh. Can you still hear me?
Yeah.
Yep.
Good. It's just my screen does not want to show you. Let's just try this again because it all crashed and lost my connection. Okay. Good. So into now water engineering. We have tutorial 2, the video, going through it. And then there is a file here called HECRAS troubleshooting. So I went through and wrote some notes about the problems you were having during last week's tutorial. So the first thing was the projection problem. This is a problem that has to do with a previous version of HECRAS. So I have uploaded another projection file for you that if you add it, it works absolutely fine. Then in terms of the unstable model, I have suggested a few different solutions because I think for different people it was crashing for a different reason. So I'm happy to sit with you and figure out which solution is best for you. But essentially, when a model says it's unstable, the first thing we need to check is whether it happens straight at the beginning or kind of halfway through the model. So if it happens at the beginning, the one thing you can check is the computational interval that we had set it to 5 seconds, and you can lower that and try different values. And then also, another thing you can do is check your hydrograph that is going in. So to make sure that it's not a very sudden jump in the way you've put the values, because the models tend to get a lot of problems while you're running a simulation. But if you change things gradually, it tends to respond a bit better. So I've got a few ideas here on how to solve it. The other thing I suggest, and that's quite a good practice to have even when you do your coursework, is remember we're drawing the center line of the river, then the bank lines, and then we're drawing one more line of where the flow is going to go. So that's okay to do accurately. But then when you start your model, it might be worth putting only very few cross sections to make sure that everything is working okay. Because otherwise you've spent a lot of effort putting all the cross sections and it's difficult to find a mistake. So you can put, let's say, 5 cross sections, run the model, see it runs okay. I'm sorry. And then just increase the complexity of your model. So that's quite good in general in terms of modeling to do it. Okay, the other thing, so now in the projection file and terrain data, there is a projection edited file that if you upload it on your tutorial, you should be able to make it work. Now, the other thing for today I would like to discuss a bit is that we did discuss projection files, but I didn't actually explain exactly what a projection file is. So I wanted just to, for a few minutes, just to go through a few slides and explain to you what the projection does in the model, because it's a very important thing that works on the background. So we'll do that. I've put the slides here, but I'll share just some notes with you. Okay. So the first thing that we did when we did the 2D model is we uploaded a file that was called a projection. And before that, the RAS mapper, so the way that we are visualizing all the maps and projections, was not actually able to work before we gave it a projection. Then when we overlaid the map, it didn't actually match exactly the location. And I told you probably there was a problem with our projection file. So map projections are just a process that is used a lot. And it's how we transform a sphere, because our Earth is a sphere, into a flat dimensional surface. And it's essentially a mathematical equation that we use for each point to be able to represent it on the flat. So there are different ways and there are different shapes that we can use to actually do this. And most of the time, the Earth curvature is something we don't take into account in our calculations or as engineers, but when we do very large area surveys, especially in surveying, this is something we have to consider. So just to give you an example, if you take a football ball and you cut all of the different hexagonal shapes out, what you will end up with is something like what you see on the right, which is not exactly the shape that you would expect. When we are used to the picture that we see of a map, it is a very rectangular shape that fills the whole map throughout. But if we do it realistically, it would look something like this. But that's difficult to do in terms of our Earth because we don't know where the different parts connect and so on. So we try to do something like this. To project it in a way, if we were to rotate the one on the right and rotate it 90 degrees, we try to create a shape like this. But as you see, this is a distorted shape. And when we're closest to the equator, so the middle part of our image, it's not as distorted as it is on the edges. So what does that mean? We have a picture from space of the Earth as it is, and if we were to cut it in pieces, it would look something like this. So if you imagine those shapes, if we were to rotate it completely and close it, I forgot I don't have my camera. I'm actually gesturing on the camera, but you cannot see me. If you close this as a shape, it would create the sphere of the Earth. But as you can see, if we zoom in here, you see Spain, Italy is here. Those parts are not connected. And if I overlay this with a map on the background, what is done, as you can see on the maps that we're used to seeing, is those shapes have expanded, they've been distorted. So from this, we end up with a map looking like that, which looks very nice, but it actually gives us a very distorted idea of the size and also the location of some of the places. So what we have to compromise when we do this to unroll our Earth and do it flat and see it flat is we have to compromise distances, shapes, and areas. So it is a mathematical equation that uses the sphere to just create it onto the flat surface. And there are different types, so essentially different mathematical equations and different algorithms that we can use to represent the Earth. So there are the type of equal area, which shows correctly the size of a feature, the conformal, which shows correctly the shape, equidistance shows correctly the distance between two features, or the true direction, which shows correctly the direction. Because otherwise, if you look on a map, if everything is distorted, you might say, to move from one country to the other, I have to move northeast by this many degrees. It won't be actually accurately the correct direction. So the main techniques that are used are the azimuthal technique, conical, and cylindrical. So there are different ways of seeing from different sides the Earth. And imagine the squared part is the piece of paper, and we are actually either turning it and rolling it into a cone or rolling it into a cylinder. So this sounds good, but a bit theoretical. But if you look at the pictures, this is a conical projection technique. This is a cylindrical one. This is the map that we're most used to seeing. And sometimes we see maps like this, sometimes in geography class and so on, the azimuthal ones. And they're not just those ones. There is a website that you can go through, and there are a lot of different projection techniques. So for all of those, you can download a file that you can upload onto HECRAS, and it tells how to actually represent different places. So the quality, I don't think it comes up very well, but you can see the amount of different techniques there are. So there are some that are very known. This one, the Mercator on the bottom right, and the Lambert one here. And there have been projections since ancient times, since ancient Greeks, but essentially the ones we use. So Jamie says, so if you know the projection Google Maps uses, your projection could maybe tie in perfectly. Yes. So it depends on which one. And actually, I've given you a website, and that one, there is a downloadable file that is called Google Projection. Not that I know which one the Google Projection is. Normally is the Mercator projection that we use. The problem with this, the one that we're using, I just had to adjust tiny bit the projection in terms of the file, because I think it was just our version in 5.7 that we were using that was having a bit of a problem. But essentially, whatever map you're using, if you want to overlay different data, you need to know in what projection that data is taken, whether it is a map, whether it is DTM data, digital elevation model data, and so on, because it needs to actually overlap. So this one is the Lambert conformal conic projection. That is like taking a cone on the top of the Earth, like putting a little party hat on the top and then opening it flat. And this is the transverse Mercator projection. The problem with this projection, that is the one we have seen a lot in all the maps that we know, is that it is not actually a realistic projection. So on the maps we're used to seeing, the blue shape represents Greenland and the pink one here represents Africa. And if we overlap them, they almost look the same size due to that stretching and well, that is not as realistic of a representation on the edges of the map. But if you actually overlay Greenland on Africa, it is a very small part of Africa. It's much smaller. So this is a GIF that shows you the true size of different countries. We're used to seeing Russia as a very big, enormous country on the side, which it is. It has a very large area, but it's not as big. And if you see this part, Greenland on here, compared to Africa, it's actually decreasing. So we've made this map because we're using it more. Europe's representation is a bit better and around the equator, but as you're moving more north and south, it is actually very misleading of what we understand of the different countries. And a way to understand this, there is this tool. So I've put the link and you can do it. Let's see if it works well. So on here, you can draw a circle. You can draw a circle of radius 10 kilometers, let's say. So if we zoom in, if you draw the circle, new circle here, let's put it on in London. So this is a circle which is 10 kilometers in London. If you start drawing, so let me draw. It's not letting me draw on this one. Anyway, I will put the link so you can try. It's giving me, just save this link. It is not doing it here very well. It is okay. Essentially, if you draw a circle of the same size at different locations, you will see that distortion. You'll be able to understand how it's distorted, and you can draw a map by yourself. It's just not working with Chrome, but I don't want it to crash at the minute, so I will not try too much. But you can see what the same distance, how exaggerated it is in different locations. So just a very quick video that I wanted to show you, because that has to do let me just make sure that I'm sharing the computer sound as well. this is all I just wanted to say about projections, just because we did talk last week about projections and it didn't work as easily, and I just want to explain what they are. So you can choose different projections and you can try different projections. What I have done is I have downloaded some projections onto my computer, and then I've done a video of changing the projection. You can see how the maps don't overlap, but it's not something you need to do. You can just upload the file that I have given you and do it like this. So the other thing that I want to work on today, which I was hoping to do in person, but it is not as easy online. So under week 5, I have put online those slides that I just discussed, and then I've put a file called input data for HECRAS models. So this is a file I want to keep updating, so I'll update it next week as well with some additional information. But it goes through how to essentially upload digital terrain model data onto HECRAS so that you can do it for your own coursework. So ideally, I would have asked you now all to do it, but I will do it in a bit, but different people are in different places. So I have also created a video of how to do it. So I've written the instructions, but also created a video. And then I have also discussed where you can get projection files. Then next week, I will add some information on how to put hydrographs and make sure you finalize your models that you're creating for your coursework. So this brings me to your coursework. So I've put the video on here as well. So for your coursework, which I would have liked to discuss in person, no, not here. I'm not ready to submit. So for your coursework, we had this week and next week to work there together on Fridays, and then you had one more week to finish it off. But what I have asked you to do is to monitor a river stretch of your choice. So it will be very similar to what we did for tutorial 2. So if you haven't finished tutorial 2, you'll have to go through tutorial 2 just to get some information. So you're responsible for monitoring the condition of a river stretch of your choice. So I've said minimum 5 kilometers. The larger it becomes, the more difficult to solve any problem. So it doesn't have to be very long, a bit like what we did for the Medway. I would like to be in the United Kingdom and sorry, just flowing through a city so we can see the effect. You will download digital elevation model data, and I've given you instructions on how to do it. And then you'll create a file exactly like we did for tutorial 2, just for your own location. If you are already there and you do it, you can just input a steady flow scenario, put, I don't know, a value of some cubic meters per second. We can discuss individually for each of your rivers. And then next week, I will show you how to put a hydrograph that we can actually design for the different locations. And you'll get some results out of that, some maps to plot. And then what we'll do is we'll increase that hydrograph by 20%. This will be our second scenario, and that will be our way to investigate the impact of climate change. So I have given you some information on what to include. I just want it to be a 2-page technical report, including the figures and references, so not very long. Pictures and screenshots give a lot of information, graphs, and so on. So I just want a small introduction. I've explained here the methodology. So I used HECRAS, this and this version. This is the data I used. Scenario 1, scenario 2, and then some discussion on the results you got. So the structure and the way you present your answer will also be marked, but it's mainly the technical content. So what I was thinking, if I just share this, going back to this one. Let's see it all the way to the end. Is I was going to offer you an extra session, either in person or online, because I know a lot of people are part-time and it's difficult to come in person, because we only have one more session with me on the spot. So I can run a session online that you share your screen and I help you troubleshoot and work on your tutorial. So I was thinking we have next Friday, we do next Friday in class all together, and then maybe on Monday or Tuesday, you'll have a few days to work more on it on the weekend and on Monday. Maybe on Tuesday we can find some time to, well, for me to have a session, and I can do 2 different sessions, some people in person, some online, and we can discuss your models, because it's difficult for me to see with everyone on the same call remotely. So this is what I wanted to discuss in general. We have an extra hour, so first of all, are there any questions before we say anything further?
You said this was going to be your last sessions with us?
No, so we have one more next week before the coursework is due in the labs, in the computer labs.
Mm-hmm.
But as you'll be working on it, I'll turn on my camera now. I thought you might need some extra help. So if you think that would be the case, we can add one more session, obviously, because we are missing this one now, and it's going to take some time for people to install the software and so on. So we can.
You mean before the coursework?
Yes.
Okay. Yes, it cuts off a little bit there.
Yes.
I thought that you were leaving us.
No, I'm not leaving you. You'll have me for the next thing. But I just thought I'll close my camera just so I don't get cut off. I just thought that because it's different for me to work around, so that was my plan for today, to have you set up all your DTM models and so on. We can just have an extra session. So in case there are any issues, we can work on it in person and I can help. So you don't all panic that it's coming soon to the submission. But what I suggest, if there are no other questions, what I suggest is you can all work on installing the software, going through some details. I will be on the call and you can ask me any questions you might have. So just do it a bit like a tutorial. And I'm happy for you to share your screens. We can also move to another room, do a different room, and I can help you. Are there any other questions?
So we should follow the tutorial that is on Moodle to upload our own information on Hecras?
Yeah, so the first thing would be to choose a location in England. So I have said the United Kingdom, but there is not always as many available free data for Scotland, for example, or Wales, but there are for some locations, so it will be up to you to see how to do it. But if I just share the screen again. So if you go on here it just tells you, it walks you through how to download data and put them on your on Hecras. So I can show you how to do it on the spot. I've done a video on it as well, but if you think it's helpful, I can demonstrate now live. But if you need some time to install software and so on, I can give you a bit of time, but you just all have to tell me a bit where you're at with different things.
Maybe having a look at it right now would be helpful. I don't know.
Okay. So I can show you how to do it now. Let's share this screen. I will move this to the side. So the first thing, does not want to do it. So I'm explaining what digital terrain model data are. And there is, here I've put some other information. You can click on here and just go and get some more information, what the data is, what the accuracy of that data is, for your own time. So we will follow the instructions. So the first thing is to open this website. So this is the DEFRA and Environment Agency website. It's a bit of a slow process. So I've done a video of it as well, so don't panic if something doesn't look too clear. Let me just open this one so I can follow the exact instructions. So there we go. So this is the website. And it has a lot of data. It's a data set that has been created by the Environment Agency. How they do it is they use a technique, a surveying technique, using a LiDAR. So what they do is they connect a laser scanner at the bottom of an airplane and fly it over low ground around the UK. The laser sends the LiDAR sends a laser down, which is reflected, and depending on how long it takes for the laser to be reflected back, it can actually calculate what is the elevation of the ground. So it sends the laser gets reflected, and based on the time it takes to travel, because we know how quickly light can travel, we can actually calculate the distance. So it creates a three-dimensional model, terrain model of the Earth. So the Environment Agency updates this data quite a lot because for different reasons, for surveying reasons, there are a lot of surveys happening throughout England. So what you do here is you can zoom in into a location, but what you can do on the top left, you can look for a place of interest. So as we've done our example for Chatham, I'll just zoom into here and it zooms in through to the map. You will see here that it has some squares, TQ77 Southwest and so on. This is the way our maps are divided based on Ordnance Survey. So it's to refer back that our whole, the whole of the UK is separated in little squares that we have a lot of information. So the section we modeled last time was starting somewhere here in Rochester, if you remember, was going through this curve, and we stopped somewhere here. Some of you managed to get all the way to the end, to the sea, but this is the main area that we modeled. And if you look at it, it actually is divided in 4 different squares. So we will get data from different Ordnance Survey locations. So what you do is on the right here. So if this is hidden, you have a button here called download your data, one here that says the list of data and some information. So you're accessing the system as public. So it's a public system. So you press on here where it says download your data. And it says here, drag a zip file. You can ignore this part. And then it has here a little polygon drawing shape. So if you press this button, it highlights it blue. And what you can do is create a polygon around the area that you're interested and you want the DTM data. So I will start here. You see it draws a line. I have to click in my area of interest. Maybe I'm interested to go here. And then when you are ready to finish, you see now I can still draw around. You double click, a bit like we did for the Hecras tutorial. And it highlights the polygon of my interest, and it is now yellow and highlighted. Now, if you scroll here on the right a bit down, sometimes it doesn't appear on all the screens straight away. It has come up with a new something else you can press. It says download your data, get available tiles. Tiles, it just means the different layers that you can download with information for the location of your interest. I'm losing my voice again slowly. So you press on here, the download button, and then it starts loading. This might take a bit of time, so depending how big your location is, how much data is available, do not panic if it just takes a bit of time. It just takes some time to load. So let's give it a minute. And it comes up with a new screen. So sometimes it takes longer, sometimes less time. And here you have a lot of available information. So what we are interested in is the LiDAR composite DTM, so digital terrain model. So that's the one we select. And if I go back in to my files, this one, over here, I have said more information on the model, its accuracy and mapping techniques. If you press on this, it goes onto the government page. Good, so you can reference this page that you got your data from here. And it explains the details of how this data is acquired. So this is a digital terrain model. It tells you it has an accuracy of plus or minus 15 centimeters. And it gives you some information. You can look for all other data of what information is available. But what we do here so if you select LiDAR composite DTM, so the digital terrain model, you get here a choice of the year. Always select the most recent one. So sometimes there might be only 2017 data, that's okay. But if you have a choice, it just means the data has been updated. Then the resolution is how accurate the data is and what resolution, so spatial resolution, you have information. So we want the finest information, so 1 meter. That just means that every 1 meter, they have taken a point and a measurement and it's accurate to each meter. Again, in some locations, you might not have the choice of selecting 1 meter. It might be a 5 meter grid. It doesn't matter. Just choose the finest resolution you can get. So the smallest number. It's always meters here. So I've selected this. If you see, if I change it to 2 meters, it changes down here the name of my file. And it has come up with 4 files, okay? So now what you need to do is download those 4 files. So you press one of them and it comes down at the bottom like a zip folder that it downloads it. Then you select the second one, does the same, the third one and the fourth one. And depending on the topography, how much data there is, how detailed the topography is, that might take longer or less time, but it's installed in a zip file just so it takes less space and it's faster for you to download. So now you have, yes?
Hi, Joanna.
Mm-hmm.
You said, was it 4 or 5 kilometers?
Yes.
Like the length of, so should we do the polygon with that in mind?
Yes. So you can do it a bit bigger of what you're actually going to measure. So remember in the past, we kind of designed through here. So just make sure that the part of your river around 5 kilometers, I mean, I'm not going to measure. If it's 4 kilometers, that's okay. I'm not going to sit down and measure. But make sure that that part of your river is included and all of the floodplains on the side. Because the bigger you draw it, the more data is going to download and it's going to make your simulation slower. Okay?
So do you just estimate or do you just?
Yes, you can go on different. Let's say I go on to. Let me just open this. If you go on Google Maps, and let's say I'm interested in the reach that I did in Chatham. To get a bit of an idea, what you can do is zoom into the river, right click, and say measure distance. So if you measure the distance, as you're adding points, you see that that's 700 meters. 5 kilometers is not actually that much in terms of the central line of the river. So what we did last week is about 5 kilometers, okay? So that's about 5 kilometers. So the way I've selected my polygon is to include this area. Now, you might want to make a bigger polygon. You just need to be aware that the more information you download, the smaller your computation, your model might be. Okay, but you can get a bit of an estimate because maybe then you can right click here and clear the measurement. Because maybe you want to go into London and measure part of the river Thames here. So again, you can do measure distance and have a bit of an idea.
Okay, sounds good.
Okay, so you can get a bit of a rough idea. It's just to give you enough area to put a fair number of cross sections. And again, I can discuss specifically case by case based on what you choose. You might want to choose something that is close to your house or so on. So now we've downloaded the data and they are all here. I downloaded them again yesterday for your video, but they are all here on my downloads. So you don't have to extract what there is. You can just double click on one of them. And you'll see that we have a folder, another folder, a TIF file. That's the one we're interested in. Another one, TFW, and one at the end here, which has a .tif extension. But the one we're interested in is this one. There is no way to open it. You'll double click it. It gets struggling to find an image to show, but it has a representation of how I'm sorry, it looks. So what you want to do is go, let's say on your desktop, create a new folder, which I will call terrain data. And what I will do is I will move this file onto here. Then I will go back and do it for all other folders. So there is another TIF file here. And there is a third one here. And then there is one over here. So now in this folder, I have 4 images that have the extension TIF. So now we can go onto HECRAS. Maybe, maybe not. I think it needs a second. Let me close some of the things I have open. That might help a bit. I'll close all of those. No, it does not want to work. So I cannot search for 5.0 because my menu is not working, but I will use the 6.10. But I would really like to use the other one, but it is not working. So let me just try to find it here. And then there is a storm and it's my computer that has crashed instead of. There we go. So, okay, 5.07. So same way as we did for the tutorial 2. You start with a project. I'll call it demonstration. Oh no, before I call it anything, I need to select where it's going to go. So on my desktop, I will create a folder called live demo. And in here, I will name it demonstration 1. So now I've created my project. I've created my project. Remember, you can write a description, a helpful description, not the one I'm writing, and demonstration. Make sure it's always an SI unit. If it's not, you can go onto here, unit system, and change it to the metric system. Otherwise, your results will be very confusing. Then, as we did for tutorial 2, you go on here, the RAS mapper. And the first thing we need to do is set a projection for the project. Now you know what the projection is. So on here, I actually found on mine, be careful with yours. So on the 6th version, it's okay. But on the other one, on the 5.07, the units are in feet. So change this to meters straight away. Now I'll find one that I did. This is the one I've uploaded for you to use. You can use it directly. And if you upload it, you see that it comes up here with some information. If you read the first sentence, it just says World Mercator. So that's the name of the projection we're using. So even though I've just named it edited projection, you can figure out what projection you are using. You can select apply and OK. And nothing happens when you do this. So this is me going exactly through the steps in tutorial 2, just with the data now. So what we can do now is right click here and say create a new RAS terrain. So this is where we're going to input our terrain data. So on here, you press the little plus button. You find the data, which I could have put into the whole folder of live demo, but it's okay. And you select those 3 TIF files. Now, if you have downloaded the incorrect files and you have copied the incorrect files, you will not be able to actually see any files here. So if I go into my downloads, over here, remember there were some additional files. I cannot see any of them. That's the only one I actually can put here. So if no files appear, check again which type of files you have downloaded. So you can shift and select all of them. And then you can press open. Now, there is a button that I didn't tell you to use last time, but you can. If you click on here, it says merge inputs to a single raster. It just means take those 4 files that I've given and make it a single file. Sometimes that's just easier in terms of the simulation on the background. If you do it or don't do it, it doesn't actually change anything in the output you're getting, but sometimes it is a helpful thing to do. So we press create. It starts giving me some warnings. Now that you have started doing a bit of numerical modeling, red and warnings are very usual. Do not panic with seeing red unless it says error, very big error, fatal error, something like this. Warnings are just things that are not working very well, but as you can see, here it says that for this band, it doesn't really matter, the destination node data value has been clamped to something. So the software on the background has actually done some edits because the values we gave it was out of the range that it had. So it adapts, but it tells you what it's doing on the background. So some red is not terrifying. Red that makes our simulation not run, that's when we have to worry. Okay. Taking a bit more time. So again, I have made a video of myself doing through this at the same time, so you can always refer back to it. It's good to show you live. And good, Harkern has access to the system. That is good. We are trying our best to accommodate things that are out of our control, like the weather today and so on.
I did want to ask, it might be a dumb question, but
No dumb questions.
when I go to the remote desktop, I have to, I'm assuming that I have to do it through, I have to do it on that desktop, not my own desktop when I'm downloading these things.
Yes, exactly.
Yeah.
So if you're using your OneDrive, for example, you can download them from your computer, the files, and then access them from that one. But essentially, it's like you are going into the computer at the university, so you don't have access to your own files. It all works as a virtual desktop.
Yeah.
Parker, did you have to do anything different to connect the remote desktop? Because Stephen's having problems connecting, and I've sent an email request for help to IT. I just want to find out if you're having any if you had to do anything special to get it to work.
No, all I did was open that file and press that, just press that file that they showed me, and it just worked.
Okay.
Yeah.
Yeah, because I saw Anna doing it last week as well, and it was very straightforward. Okay, so I'll just continue with this. Now it says terrain complete. I will close it, and we can see our terrain here. Now we can tick the map layers and say add web imagery layer, and we can select one of them. For example, Google Satellite. You can choose something else. And if you remember, it overlaps completely, so we cannot see. So by pressing the plus, you can see the Google Satellite. Edit, double click, because you can edit its transparency. And then we can do the same with this one. And we can see that it is in the correct location, which is good. If you zoom in, it is pretty accurate. You can also try to add some different ones, so OpenStreetMaps, for example. We can remove the Google satellite, make it a bit transparent, because the OpenStreetMaps also has some additional names of what is happening. And there we go. And from that now you can move to the next step that we did, the geometries. So you can do a new geometry and then start drawing the central line of the river, exactly what we did with tutorial 2. So if this was my coursework, I mean, I keep doing Chatham, but it could have been a different location. You would just continue from this point, draw it, and then put some flow in. It doesn't matter if it's the final value, you can put a hydrograph like the one we did for tutorial 2, or a steady flow rate, just to make sure that it is all working and is not giving you any errors. And then we can go ahead and make it a bit better as you start working on it. And because all of you will have different locations and different places, some of you might have similar ones, but because you'll have different ones, it'll be, I think, more helpful for me to help each one of you separately. So next week, next Friday, I'll walk around and you can be working on it, and I'll give you some additional information on how to improve it and so on. And every time, if you have an issue with the model not running, I can help if you give me the information. So for example, last week the projection was not working. I did it myself, figure out what the problem was, and I can help you troubleshoot a bit faster. I have gotten many errors many times, so I am a bit faster at finding the solution, but it is something that you need. So all modeling, especially hydraulic modeling, if you choose to do it at some point, errors and simulations not running are part of the routine in a way, because there are a lot of problems. You're trying to create a very complicated three-dimensional balance of nature, pretty much, in a software, either in 1D. This is a 1D model that extends to 2D on the floodplains. So to do this, you make a lot of assumptions, and sometimes our models are struggling to find different things, but there's always a solution to improve it. And if you get stuck, I'm happy to help, as long as you tell me that where you're stuck and what the problem is. And it should be something interesting. You can see a map, you can see where the water is going to go, and we can create some extreme scenarios. People wanted to flood their hometowns very badly last week. So I think the first step is for you to choose a location to do your coursework, and then go through the steps, find the data, see if data is available. If it's not, maybe choose a different location, and then go through tutorial 2, but for your own location. Are there any questions?
Would you mind us emailing you about any problems that we have,
No.
Rana, just because we're not, you know, where we're not sort of with you to work on this?
Yes, that's absolutely fine. And if it's a general question, I might share the answer with everyone. If it's something that's where I got stuck, you know.
Yeah, great. Brilliant.
So I'm happy to do that. In general, HECRAS, because it's used very widely, there is a lot of help online as well. So sometimes you might find a quick answer online as well. So always look for that as well. But yeah, feel free to email me with any questions. I'll try to get back to you, you know, as quickly as I can.
And just to save me going right back to the beginning of that lecture,
Yes.
I can't find the link on Moodle for the DEFRA, and I've been looking on DEFRA for the.
No, it takes a while to find. But if you go on Moodle, I will put the link. But if you go on here, I've made a file called input data for HECRAS, part 1. So next week I'll give you some extra information. And on here, I've given the instructions of how to do it. And this is the link here. So
Okay,
I
I've
will
got it
share
now.
the link. I can put it anyway in the chat.
Yeah, got it. Brilliant. Thank you.
No problem. Any other questions or something?
So for the coursework, we need to like explain what we got in HECRAS,
Mm-hmm.
the results and everything.
Yeah, so it's up to you to choose what results you show me. Again, we can discuss it, but maybe a map of where the water is, compare it with your second scenario that will do a bit more of an extreme one for climate change and see what the differences are. And just to give you a bit of information, this is the location I chose. This is the model I use. This is where I got the data.
More or less, how many words would it be?
I've set a 2-page limit. So depending on how many images you choose, it should be very short. I mean, sometimes technical reports, I don't expect you to write a lot. I'm more interested in you spending the time doing the modeling on HECRAS.
Mm-hmm. Okay.
But it's important to say, I have used HECRAS version 5.07, let's say. I got the data from the DEFRA website, so and so, just to give references of where you got the information, and then the results, just a small discussion of the results. So I don't want you to spend too long writing, you know. You have already shown us that you can write long reports. Now the point is more to spend the time getting, you know, comfortable with the software.
Mm-hmm. Okay. Thank you.
No problem. Any other questions? You can write on the chat as well if you have a question and you cannot speak.
So, Joanna, in summary, we just select our area, go to the DEFRA website, copy the plan, overlay it in HECLAS, and then basically go through the same procedure that we did for the second tutorial, and then get the results, and then, you know, share the results, basically.
Exactly. So the only thing that I will show you how to do next week is how. So remember that I gave you a hydrograph that I said, let it start at 10 cubic meters, go to 1,000. So if we go to last week, so on here, when we got to this step, somewhere, so when we got to this step here, remember we put some values for the hydrograph to run over here. So what we'll do next week is we will try to put values that are reasonable for your own river. Because maybe if you choose a very small river, 1,000 cubic meters per second might be too much. If you choose a very big river like the Thames or the Medway, maybe that's not too much. So I'll just help you change this hydrograph so that it's relevant to your location next week. And then you get the results based on the hydrograph that we've created. Then you create a second hydrograph with 20% increase to consider climate change. So this one would be, the maximum value would be 1,200 if it was 20% up. And then you would compare the two results. Make sense?
Okay, sounds good.
Good. Any other questions, anyone? So if not, I say make sure you have Hecrest installed on your laptops at the moment. We have another half an hour. So make sure you install them. If it's not working, if you're having issues, I will be here for another half an hour so I can help. Then, if you've done it, start thinking a bit of the location you want to model and have a look on the DEFRA website to see if you can find available data. And yeah, I just want you, even though, I mean, I don't have anything else at the minute to discuss, but I would like to spend this half an hour to make sure that it's all working correctly. Everything is downloaded. You know where to find the data and you're not missing any information. And if there are any questions, I can actually answer.
Yeah, I had one. Do you know the polygon that you drew at the start?
Yeah.
Fine. What was that? So we have to do it over 5 mile. Sorry, 5 mile span. Was it?
I said to try and model. So in your coursework, I have said to model about a 5 kilometer stretch of the river, which is about what we did for the tutorial too.
Okay.
So this polygon should just include this length of the river that you're interested and the floodplains around it.
Okay. Yeah. Thank you.
No problem.
Stephen, have you now been able to get into the system yet?
No, I still can't have the access, but I'll keep trying.
Okay, I haven't had any response to my request. So it's not letting you into the remote access software.
Yeah.
Maybe Harkaran, which software did you use? Did you use Safari? Did you use Google Chrome? Did you use, what did you use? Because sometimes
I used Google Chrome.
Google Chrome. Harkaran, what did it work with for you?
Yeah, Google Chrome.
Okay. I thought maybe I solved the issue, but no. Sometimes they seem to work with one and not with the other one.
Yeah, they do, because I use Firefox and a lot of things don't work with Firefox on the university server. You have to use Chrome. Yeah.
What is it that he's actually? What is it that he can actually see in this on his screen? Because when I did it, it was just literally that PDF file, and then I clicked on. Yeah, I just clicked on the link. That was it.
I was going to ask Stephen if he wouldn't mind sharing his screen and showing us what he's trying to do so we can see.
All right.
Okay. So that we can see the error.
There's also an alternative at the end of the PDF where it says for iOS and Mac iOS as well, if that helps.
Yeah, so you've opened up if you open up that, yeah. And then you're going to copy and paste that into your browser.
All right.
Okay, and you're using Chrome, yes?
Yeah.
Unless the access hasn't gone through yet.
Yeah, I'm wondering if the access hasn't gone through yet. He said, obviously he said he had done it, but yeah, copy that to a new page and see if it
Yeah.
Yeah, so it's not giving you access. So it looks to me like it may just not have gone through yet. So we'll wait and see.
Well, the problem is it's Friday.
I know, and they will not have been on campus today because campus was closed.
No, but have you sent them another email, Cecilia,
Yeah.
saying that it's not working?
I've sent him another email saying it's not working. Yes. So I sent him an email at 3:09.
They tend to be quite quick, so if we give them about an hour, maybe. I mean, he has help today. He gave Harkern the access within 10 minutes that I asked.
Well, and he had originally said that he had originally provided the access very quickly for Stephen, but it doesn't seem to be working. And I don't know if there was a typo when he attempted to when he gave the access. But the technicians over in Hawk. Well, no, he's a IT technician.
Yeah.
I was going to say, oh, wait, he's just come back to me.
Sorry, I'll be back in 1 second. I'll just get some water.
He says, double check to make sure you're in the group.
I'm sorry, what group?
Are you in the, you're in the, well, I'm going to just check and make sure that you're in this team. I don't know which group he's talking about, so I've got to find out. But I know that for teams, we have, we have members in our teams. Let me see. Let me just check. Let me manage the team and make sure Stephen's in the team. Members and guests. Yeah, you're in this.
But which group is he talking about?
No, I'm about to send him an email and ask him, which group are you talking about?
So just double check that he's definitely in the group. Which group?
Well, I've just double checked, and he's most definitely in the Teams group, and I'm pretty sure he's in the Moodle. I'll have a look and make sure he's listed as an active participant.
Maybe when you reply, Cecilia, write Stephen's full name as well, just in case. I don't know. He's copy pasted something.
Oh wrong. Yeah, I forwarded him Stephen's email, which had Stephen's full name.
Mm.
One question, Yona.
Yes.
When we choose the river, is it okay if we choose one that has like bridges across?
Yes.
Interrupting it.
Because we won't really model any bridges. So ideally, you would model the bridges, but we won't at this level. So maybe choose bridges that don't really affect the flow.
How do I know if they don't affect the flow?
Can you see a picture of them? Because if they just go completely over the river, they don't affect the flow.
Oh, maybe I can show you.
Mm-hmm.
Because I'm looking at rivers in England
Yes.
that are around cities.
Mm-hmm.
And I found this one. 2 seconds.
Okay.
Can you see my screen?
No, not yet. Ah, now it's doing something. Yes, I can.
So I'm looking, and it has to be 5 kilometers, no?
Something like this, yeah.
Mm-hmm.
Okay.
There's a river crossing here. I mean, a bridge crossing here.
Okay, well, so we will go.
And one here. It's like a road or something.
So when you're there, you stop. If you right click and stop measuring the distance.
Okay. Clear measurement.
Yes. And now, for example, the bridge, the first bridge that you have where it says the Trent Bridge in.
Oh yeah, this.
You would have a name of the bridge on the bridge, and you click so you can have a look.
Bridge.
Yeah, press on that one. Let's have a look how it looks. So this one would have an effect because, so if you imagine that the river overflows, it would actually create a problem in the piers or if some water comes through.
Like here.
The next one, the A6011, I don't think this one has piers, because when a big road goes over a river, it tends to be newly constructed. So maybe I would just move a bit to the side. But if you're very interested in a location that has a bridge like this, we can ignore it for now. So you can go through and just ignore and say there is no bridge. But in your report, when you discuss maybe the limitations, you know, you can say, in terms of limitations, hydraulic structures such as bridges were not considered, which in the future would be considered. That's okay at the minute.
Okay. For example, this one.
Yeah, this one would have less of an effect because it would have to be a very extreme event to actually fill the hole up to the bridge. The other one, because it has arches, they might actually fill much easier.
Okay, I'll see. Maybe I can find a different geography because this area seems like it has a lot of structures.
Yeah, but it can be a bit before. So if it starts from Clifton Bridge, for example, to the next bridge, that might be about 5 kilometers. So right from Clifton Bridge, on the right of that, up to Wilford Suspension Bridge. Maybe that, you know, something like this. You can have a bit of a look. Maybe it's too small, this one, but if there is one, it's okay. You can ignore it and keep going. You know.
Okay. I'm thinking maybe I'll do this.
Yeah.
This part.
It's nice to do a part that you either know. If not, that's okay to have a random one. So if you can avoid bridges, avoid them. If not, just make sure in the report you mention that we haven't modeled bridges, and that's a constraint of the research that in the future it should be considered. We're not going into any extreme detail. I just want you to be able to model, to learn the basics of modeling. And then if you were to make this model better, you would include the bridges and so on throughout.
So, hello? Do we have to use the polygon? We can just use the freehand tool?
You can use the freehand tool as well.
Okay, because I'm having some problems with this polygon.
Yeah, that's okay. Yeah. I find it easier in my mind, but sometimes it doesn't matter. As long as the stretch of your river that you're interested in is included and the floodplains around it, that's okay.
Okay.
Any other questions? Anyone else?
Can it be smaller, like really small rivers? Like, does it have to be a huge one?
No, it doesn't. But just if you do a smaller river.
Yeah.
Do you remember that NRFA website I spoke to you about? So let me just share my screen again and I'll explain what I mean. I don't mind about the size of the river as long as there are some structures around it. So if you go on this website, the National River Flow Archive,
yeah,
you can go search data and zoom in. So let me zoom into a river. I know that it's small. So over here, this river, I think, is small. And it has a station. If I go on this one, I can see the daily flow data. So if you see the data on the left, you might be able to get peak flow data. Let's have a look at that one. You see, over all the years, the maximum flow that it's experienced, sometimes it's 30, sometimes it's 15 meter cube per second, okay? So when you go through the tutorial, instead of putting a maximum flow for the hydrograph of 1000 that we put for the Medway, put something more relevant to these values. So maybe 30. Because if you put to this tiny river a flow of 1000, it will flood completely, and probably the module might be very unstable essentially, because it's too much water for the size of it. Okay?
Yeah.
So as long as you try with something that is more appropriate. So the Thames, a big river, 1000. If it's a considerably big river, maybe 200. If it's very small, go down to 30, 40 cubic meters per second as a maximum flow.
Could you potentially send this link as well? This link.
Yes.
Thank you.
Absolutely. So next week we'll go through on how you can select that data a bit better. But I think if you try from now, it will. This is the main website, and you go on search data over here. It's just so you can have a bit of an idea of the size of a river, essentially. Any other questions?
I'm waiting for Alistair to come back. So if he comes back, I'll send information on to Stephen.
Yeah, thank you for doing this while I'm speaking.
I'm sure we'll probably end up just emailing some questions as we're trying to get our files sorted and whatnot.
Yeah, that's absolutely fine. And I will try to get back to you as quickly as I can.
Sorry, Aaron, could I ask? I had to nip out quickly because we had a tree fall in our neighbour's garden earlier and take all his phone lines out and everything. So he just popped it to the front door. I just wanted to just quickly ask, you know, when you get this data on the download your data, there's the available tiles. Is there any preference where it's, because I've put in for the River Stour in Canterbury, so just to see, because it sort of branches out down towards near where I live, and I thought it might be interesting to look at that because it floods quite a lot. But I've just got a big long list, and I wouldn't know. Would I just download all of those available tiles?
No, because you would get far too much. So
no, and have you seen the? Paul? Have you looked at it on the map to make sure you're not? We've got a few river Stours in England.
Oh yeah, I did. I did the, but I probably did a fairly large pentagon around it.
Okay.
Because I was just looking at the 6. It was like I went to the scale bar, came up as like 6 kilometers. So I just did it around that. So I might have.
But that's okay. You see that here it's within 4 of the tiles that I have. So I'll get 4 files, which is okay. So if you go
right, okay.
They get available tiles. It will come up. I said this is the moment I was saying that it takes a bit of time because it finds all the available data. Let's give it a moment and I'll show you again.
So it doesn't matter how much tiles because mine only have 2 tiles.
Yeah, that's okay. So it depends in which. It depends. You see, now we are kind of between the 4, but it's not the area of all of them. So on here, Paul, if you just go through and select LiDAR composite DTM.
Okay, yeah, I've got mine's around 6 tiles. So did you right click? Oh no, not right click.
No, I just pressed download data.
Yeah. Oh, LiDAR composite DSM.
Yeah. Is there a
I want
DTM?
yes, DTM. That's what I've
Yes.
got. 2020.
Yeah, you select the most up-to-date that you have, and then the smallest resolution. So 1 meter if it's possible, if not, whatever is available.
Yeah, okay.
And you see at the bottom I have 4 files.
Yeah.
It says available. If you press on one of them, I've downloaded the same files 20 times, it comes down here in my download. So if you go then onto your downloads, you'll have some zip files.
Yep.
And if you open one of them, it'll have quite a lot of information, but the file we want is the one that has a type that says TIFF, T-I-F file. So that's the one we're interested in. So that's one of them from one of the tiles. Then you have one from the other tile. So you will move this to the file, the folder you want to use. So earlier I made a folder here called terrain data. Let me close it a bit. And what you do is you essentially take this file and move it to the folder that you're interested in. If on your computer it doesn't show the type in this way, if you right-click Properties, you can always find the type of file you have here, because sometimes depending on which version of Windows, it doesn't show everything.
So only that one TIF file, yeah?
Yeah. So from each of the squares that you have, so I downloaded 4 of those folders. In each of them, you will take the TIF file and move it to the folder that you want.
I've got the tiles now.
Mm-hmm.
It says available tiles. I just click on them and download them now.
So let me go back. So let's do it again. So you've selected, if you check what I'm doing, and then you can tell me where you're at. So you've selected your area.
Mm-hmm.
Then over here, you press this button that says Get Available Tiles.
Mm-hmm. I have them.
Okay, it takes a bit of time.
I only got 2. Is that
That's
okay?
okay. Yeah, because it depends where your river is located, okay? So if our river was up here where it says TQ87SW, I would only have 1 file because it would be within this tile. So then you select LiDAR Composite DTM, so Digital Terrain Model. You select the most up-to-date year, smallest resolution, and here you might have 1, 2, 4, 6, whichever you have, depends on when your river is. It doesn't have to be 4.
Mm-hmm.
And you press on each one of them and it starts downloading them.
Okay.
Okay?
Mm-hmm.
So now I've downloaded the 4 folders. Then you go to your downloads, you have your folders. You double click and open one of those folders and you find this TIF file.
Yes. Mm-hmm.
And that's the one you copy into the folder that you will be working in. So you can cut it, go, let's say, to the desktop, create a new folder, call it HECRAS, I don't know, assignment. In here, you can make a new folder, for example. Call it terrain data. And in here, you can paste the files that you have. So 1, 2, 3, how many you have.
Okay.
Okay.
Thank you.
again, if in doubt, on Moodle, somewhere, I've lost my Moodle page, but I have opened it. On Moodle, here, I have instructions here in the input data. I have instructions of how to do it and which data to select over here. And it also has a link to a video of me doing it in case you want to see again if you've missed something. So you can press here and it takes you to the video. Or I've also put it down here, how to download DTM data. It's a short video, but if, in doubt, we can go back to that.
Okay. Thank you.
The projection itself.
Say again?
The project. So we have to put the updated, edited projection in now.
Mm-hmm.
Okay.
Yeah.
And with the so the update is that so the tutorial 2 with no sound, would that be on the newest version or is that on 5.0? That's on that's on the older version. Okay. Yeah.
So I've put both. So on here, I have actually put another video of how to change projection on HECRAS. And what I'm doing is I'm trying different files and showing you how it moves around. So you don't have to start from scratch. You can just have a projection. And then I'm going through the tools, set projection, and then I'm uploading different projection files here. So if you want to change an existing projection, you can just try. But you can tell quite quickly if the projection is working. If you zoom in and make them a bit transparent, you can say, so for example, this one that I'm trying on this video, it's not actually matching.
I have to leaving.
Yeah, it's time. So if you don't have any other questions, I'll stay around if anyone has another question, but feel free to email me and I'll see you next Friday. And we can maybe decide next Friday on another session to do, maybe the Tuesday after. So
Tuesday is a good day. Mm-hmm.
Okay, good.
Okay, thank you. Bye-bye.
I think I'm not entirely sure if Panos and Ahmed are they're joining in with the strike, or I don't know what it is actually, but I think Tuesday they might not be doing their lectures. I'm not entirely sure. They're gonna let us know over the weekend.
Okay.
The decision is, but yeah. So Tuesday might be a day where we could actually do it. It depends on everyone who's part-time as well, wherever they
Yeah, so I might have to do 2 sessions, one online and one face-to-face, but we can find some time. I say we leave it till next Friday, so you have time to work on this and maybe think of how the report can be set up. And then the week after, we can do maybe on Monday or Tuesday a session. Just before your deadline, so we can finalize things.
Yep, sounds good.
Good. I will stop this recording and I'll upload it. So if you want to go back to it, you can go back.